Today we are moving away from a discussion of assembly skeleton and beginning a discussion about product data exchange. Because we're using multiple tools in this class, we need to spend at least a little time talking about how to move data from one system to another system. And so you should begin looking at chapter 18, which talks about product data exchange. It's not a terribly long chapter, but I think there's some very important information contained in the chapter, and it's certainly worth your time reading it. So just as kind of an introduction, I think it should be obvious to each of us that CAX tools are developed on a wide variety of kernels. And then generally you cannot move a model from one system, brand X, to another system, brand Y, and have it retain all of the information, hang on to all of the strategic attributes, parameters, history tree, all of that kind of stuff. When we talk in terms of CAX, just for clarification, students here at BYU probably have heard me talk about it a lot, but our remote students, when we talk about CAX, we're really talking about design, analysis, manufacturing tools, and we use HyperWorks as a pre-processing tool, so that would be a CAX tool. In this class, we'll talk a little bit about ANSYS, or about Fluent, or Star CCM+. Those are analysis tools. We don't really talk very much about manufacturing tools, but there's plenty of CAM tools out there that kind of fit the same paradigm of being able to display geometry. Now, in your mind, hopefully you're saying, well, I think I know what most of these CAX tools are, but I found this interesting. This is what our wiki page thinks about kind of CAX companies. So just watch as I kind of page down through this thing. So those are all current CAX tools. Do we have some that we recognize? Here is the Siemens set of tools. Okay, so here's NX, NX Nastran, Solid Edge. Okay. If we go up to kind of Dassault Systems, place up there. Here is CATIA. And we should be able to see SolidWorks. There's SolidWorks, which is another CATIA tool. So there are hundreds of CAX tools. And if you're trying to move part a design from one CAX tool to another one, you're hoping to be able to do that without a lot of lost data, lost information. Are there still other CAX tools out there that are not in that list? And if so, what are they? Company proprietary. And so if you go out on an internship or you graduate and leave, you will find that your company will have some kind of application that grew up inside of their company and they have just worked it for 30 years or 40 years, and it will have some kind of a graphics interface to it. And that graphics interface may not fit anything that we saw on the wiki page. Okay? What's a geometric or a geometry kernel? Well, the geometry kernel is the lowest level graphic software that resides in any of these CAX environments. It's the underlying low-level, how do I create a line, how do I create an object, how do I display an object. It's that lowest level underlying environment. Do any of you know graphics kernels? Are you familiar with any of the graphics kernels that exist? My mouse just doesn't. Effective. Well, that's not going to come up. So, without going to this page, we'll just talk about some of them. One of the graphics kernels that's out there is Parasolid. Another graphics kernel is Romulus. Another graphics kernel is ASUS. And a third one, fourth one that's out there is Open Cascade. And so if you go to this wiki, this website, those are the 4 graphics kernels that they say are used all over the world in all of these underlying systems. It's one of those 4 kernels. The question is, are there other kernels? Well, Parasolid is the kernel to what CAD system that we're familiar with? Do you know? NX. It is the underlying kernel to NX. It's also the underlying kernel to Solid Edge and to SolidWorks. And it's an underlying kernel to about 100, 120 other CAD related tools. ASUS is another very popular CAD system. Okay. It is an underlying kernel to a lot of analysis tools. So ASUS, you can find that inside of ANSYS, you can find that inside of some of the other analysis tools out there. But the things that we're not thinking about is this GSNlib and TSNlib. Those kernels are used largely inside of universities. It's a kernel that is fairly cheap, and lots of universities license that kernel and they use it to develop research code. CATIA has its own kernel. It doesn't use ASUS, even though it owns it. So Dassault Systems owns ASUS, but that's not the underlying kernel to their graphics system. PTC has their own graphics kernel. It's not one of those 4. It's not Romulus, it's not ASUS, it's not Parasolid. It's its own kernel. When we talk about doing a direct exchange, we mean moving apart from system A to system B. In general, it's not possible, and the reason it's not possible is because of the difference of the underlying kernel. Can I move a file from NX to Solid Edge or to SolidWorks? And I could, because the underlying kernel is the same. So if I want to do a direct transfer, the first thing I have to ask is, well, what is the underlying kernel? And can I use the underlying kernel to move the geometry? Okay, and that's the exception to the rule, is if you have an underlying kernel, you should be able to do a direct direct translation. Inside of an X, if we pull down